Is the screen visible? Okay. Okay. The very first thing that you have to start with is scientific notation. Okay. Since you know it already, so it won't take much time. Okay. For example, if I have a bigger number, let's say 6 point, oh sorry, 604,000. How to convert this in a scientific notation? Okay. What else can we do? Okay. Let me tell you this. Okay. Let's say it's the game of decimals now. Scientific notation is all about identifying the decimal and putting the decimal in the correct place. Okay. Let's say at the end of decimal is at the end of every number. If it's not given over here, it means it's at the end. Okay. When we move decimal towards left, it would create a positive impact. Okay. If we move it towards left, towards right, sorry, it would create a negative impact. Let me give you an example. Let's move this decimal. It moved one place, two place, three place, four place, and fifth place. One, two, three, four, five. Is it so? Okay. So we have to write it in the form of 10 exponent 5 or 10 raised to the power 5. Okay. Now the decimal is after 6. It would be 6.04. The rest 0 we won't calculate because we have written 0 in the form of 10 exponent 5. Didn't get it? Okay. Let me give you another example. 8.3 into 10 raised to power minus 4. Now I've told you when we move toward the right, it would create a negative impact. Or let me write it like this: 0.00083. Let's not write this. Let's first stick to the first thing. This is another concept. Let's not. Okay. It's 0.0083. Let's move the decimal. Now, the decimal has to move towards the number. The number exists on the right. Is it so? So we will move our decimal towards right. 1, 2, 3, and 4. Here, it would become 8.3 into 10 raised to power. Now it would have a negative impact, so with a negative value. Have you gotten this? Okay. Tell me the answer for this one. 0.0058. Are you doing the calculation? Good. Good. Excellent. Okay. Then I have another number for you. 2, 4, 5. Okay. What would be its scientific form or notation? Are you doing the calculation? Okay, because I'm waiting for you. Wait, let's do it together. Let's do it together. Okay, decimal would be here at the end. Okay, if it's not given in between, it means it's at the end. Let's move it. 1, 2, 3, 4, 5, 6. Is it so? 7 and 8. So it would be 2.456 into 10 raised to power 8. Okay? Okay, good. Um, can I give you another number? Okay. Oh, wait. 6 point, oh, sorry. 4067. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. Write this in scientific form. 4.067 into 10 raised to power. Okay, let's do it. Let's do it. Decimal is here, right? At the end. Let's move it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? Exactly. Okay? I guess you get it now. Let's move to the another part. The another part is about the calculating the molar masses. So I would need the periodic table. Yes, we need calculate the molar masses. Let's use the screen pen for this. The molar masses. So let's start with water. Okay, so you're back. Okay, now what is the procedure to calculate the molar mass? Are you good at maths? Okay, then it will be fun. Okay, so first of all, we need to know a few things. Number one, the number of atoms, how many atoms are there, and number two, their molar masses. And the molar masses are given in the periodic table, which is the atomic mass, not the proton number or the atomic number, the other one, the bigger number. Okay, can you tell me the atomic mass of oxygen? 16. Good. So we have to work like this. Okay, let's follow the rule. So first of all, let's write the total number of atoms. How many hydrogen, how many oxygen? Okay, and one oxygen. Okay, and then we have to add them. Okay, let's write their molar masses. Hydrogen is 1.008. Okay, now for hydrogen we have to use this value. Why do we need so? Because hydrogen is 1.008. We don't use 1. Instead, we use 1.008. Okay. Why do we use this value? Because the hydrogen is really the smallest molecule, or sorry, the smallest atom, but the least mass. So we have to use like a decimal places in this. Okay. For hydrogen only, in case of hydrogen, and 1 and 16. Okay, 2 into 1.008 and 1 into 16. What is your answer? It would be 2.016. Is it so? Have you calculated? Do you have calculator with you? Okay, then it's okay. Okay, let's move to another one. I'm giving you a difficult one. C₆H₁₂O₆. Okay, calculate for this one. Correct. Good. Excellent. So there are 6 carbon, 12 hydrogen, and 6 oxygen. What mass have you used for hydrogen? 1.008. Okay, 6 into 12, 1.008, and 6 into 16, 72. What's the value over here? Have you calculated? Okay, so you did it all together. Okay, 12.096. Okay, so the final answer is 180.096. Okay. So the unit that we use for molar masses is gram per mole. Okay. Now, why have you used per mole? We say that the one molecule is equal to 1 mole. Whatever mass it has, it is equal to 1 mole. It's a you can say it's a unit that we use in chemistry for calculating the you can say mass, or calculating the quantity. If we want to calculate the quantity of a molecule, we can calculate in the form of moles. Okay. Okay. Now you know how to calculate molar mass. Let's move to moles. So the formula for moles is given mass over molar mass. Okay. The formula that we use for moles is given mass over molar mass. Let's do one example. Calculate the moles. Let's say calculate the moles of in 25.20 grams of NaCl. Okay. So the given mass is 25.20 gram, right? Yes. Sorry. What do we mean? Molar mass. Molar mass. So you can calculate molar mass, right? Sodium is 23 and chlorine is 35.5. Is it so? So the molar mass is 58.5 gram per mole. Okay. So moles will be equal to, given mass is 25.20 divided by molar mass, which is 58.5. What's your answer? 0.43 moles. Okay? Okay, let's practice more. Calculate, I'm giving you another question. The moles in 148.25 grams, okay, it's a decimal, of calcium nitrate. Now, it's a twist. How to calculate numbers if the bracket is given? You have to multiply the number outside bracket with the whole bracket. So there is one calcium, two nitrogen, and how many oxygen? Six oxygen. So I want you to do this calculation. Okay. I don't know. You tell me. Okay. So let's calculate moles. The given mass is 148.25. Okay. What is the molar mass? Have you calculated the molar mass separately? It's 40, 40, 80, 48. No, oh, wait. It will be 696. What's your total? Why it's not 204 for me? Am I doing something wrong? Really? Calcium nitrate. Let me calculate. Use the calculator. Nice. Okay. Then you can correct it. Is it 164? 164. Okay. 148 divided by 164 would be 0.9 moles. Okay, good. Now you've gotten it. Okay. The next concept is to calculate the number of atoms or the number of molecules in any substance, whatever is given. Okay, and we have to use the we use the number, a specific number, and this is known as Avogadro number. It's a scientist that has given the concept that a mole a mole or in 1 mole there are 6.02 into 10 raised to power 23 particles. Okay, like if there is 1 mole, it has 6.02 into 10 raised to power 23 particles. Whatever the number of moles is, we have to multiply it with this specific number. It's a constant value. You cannot change it. Okay, it's a constant value. Okay. Okay, what if I say that you have to calculate number of moles of this? Let's calculate number of particles, sorry, number of particles in NaCl in 0.43 moles. Then we have to multiply this. So okay, oh, how do we do this? So you may have a calculator in your hand. Do you have? Okay, now how to write exponent 23? On your calculator, it's with the decimal. What is written in the decimal? Is it exp or 10 raised to power x? On your calculator, what is written? Okay, you have a calculator in your hand. Okay, there is a zero, then decimal, Is it so? What's written with the decimal on the right side of decimal? EXP or into 10 raised to power x? Like there are two type of calculators that students usually use. Times 10. Okay. Okay. Then you have to press times 10. Okay. Now how do we do it? We will write 0.43 written multiply 6.022. Now for this scientific notation, we have to choose multiply x multiply with 10 raised to power x. Okay? And what's the number? 23. Press 23. Pressed. What is your answer? Okay. Wait. Let me see if I can use calculator over here. Just give me a minute. Let me take out the scientific calculator. Okay. What's the answer? Yes. 2.58. Okay, let's round it off to the two decimal places. 2.59. 2.59 into 10 raised to power 23. So this is your answer. Okay. Let's calculate for this. Number of particles in calcium nitrate. 0.9 multiply by 6.022 exponent, mean 10 raised to power 23. 0.9. Let's round it off to the two decimal places. 5.42 into 10 raised to power 23. Good. Okay. Then I have one question for you. Though it's a tricky question, let's see whether you'll be able to solve it or not. Okay. The question is there is a stock room that has glucose and fructose. Okay. And then there is mass given for both, and then they are asking why it's not typing over here, that which one contains more number of uh, particles. Okay. Yes. So a chemistry stock room. Let me take a screenshot rather than writing it, because like it's taking time to write the formula. Let me take a screenshot. Okay, paste. It's a question. Is the question visible? Okay, which one contains more number of molecules? Now moles are given. You have to, yeah, wait. You have to calculate the number of molecules for both. How to calculate number of molecules? I have told you just now. Moles multiply by Avogadro number. Okay. Multiply and then tell which one has the more. Okay. 1.8 in sucrose. Which one has more number of moles? Okay, wait. Both have three number of moles. Let's do it. Both have three number of moles. Sucrose and glucose. What is the molar mass of sucrose? It's 180 that we have calculated already. And for sucrose, is it, what's your value? 342.296. Is it so? Have you calculated the molar mass for this one? These are the molar masses calculated already. Okay, 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 okay. Wait. Though we don't need it, I'm just giving it to you for your reference because we have done molar mass. Let's say we have to calculate number of molecule. The formula is moles multiplied by Avogadro number. Is it so? Okay. The moles of sucrose is 3 and the Avogadro number is 6.022 into 10 raised to power 23. So the answer is 18.066 into 10 raised to power 23. Is this your answer? Have you multiplied? Okay, what does it say? Is it saying 1.8066 into 10 by 24? Okay, we will write that. Okay, let's place decimal over here and make it 24. Okay, so 3 multiply 6.022 into 10 by 23. So what's your answer? It's the same. Okay, so we say they both have same number of chromosomes. Oh, so sorry, same number of molecules. Okay, now there is another twist now. As you have gotten this, and why I've given you this example, because the molecule is different from atom. Now you have calculated the mole number of molecules num- in a whole one molecule. You're considering that substance as a one molecule. Okay? Okay. When we talk about atoms, now the number of atoms are different. In one molecule of sucrose, how many atoms are there? 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms. Is it so? Or in fructose, sorry, I've written glucose as fructose. In fructose, we have 6 carbon atom, 12 hydrogen atom, and 6 oxygen atoms. Now, number of atoms are different from molecule. For both, number of molecule is 1, but they have different number of atom. Are you getting me? Okay. So when they ask in the question that you have to calculate number of atoms, then we have to multiply this whole thing with number of atom, whatever atoms are there. Okay, let's do an example, you'll get it. We are applying, like we are doing the same example. We'll continue with the same. Let's apply it in sucrose and with a different pen. Okay, let's say moles into Avogadro number into number of atoms, whatever atoms are there. Let's calculate carbon atom. Which one has more carbon atoms? Let's make a line. Here we will write sucrose. How many carbon atoms are there in sucrose? 12 is written in the formula. 12. And for fructose it's 6. Okay. Then just moles. Wait. What means? Okay, it's the name of a compound. Sucrose is a sugar that we usually use. And fructose is another, like just like glucose. It's a name of a compound or a molecule. Okay, moles into Avogadro number into how many carbon atoms are there in sucrose? 12. So we multiply it with 12. Okay. Then in fructose, we use the same formula into Avogadro number into how many carbon atoms are there in fructose? 6, right? So we multiply it with 6. Okay. So it becomes, we have already calculated this, 1.8066 into 10 is per 24 multiply 12. Here same, 1.8066 into 10 is per 24 multiply by 6. Now you have to multiply and then tell the answer. 2.16 into 10 is to power. Okay. So which one has more carbon atoms? Sucrose. Sucrose, right? Okay. Um, Let me give you another example, another question. Sorry, I'm taking time to get the question for you. Okay, formulas for all these. Shall I write it separately? Okay. The very first thing that we did was the molar masses. How to calculate the molar mass? We just write the number of atoms and then write their masses and atomic masses, and then we add them. Okay. In the second one, we have calculated the moles. Moles are equal to given mass over molar mass. Okay. For what? Okay. For the first one, let me write here. It's, we'll write number of atoms, then whatever is their atomic mass, we need to know that, and then we add them. Okay. The second one thing that we did is moles. Is given mass over molar mass. Given mass means whatever is given in the question, and molar mass we can calculate, right? Okay. The third thing, the third formula is about the number of atoms or the number of molecules. Okay. For number of molecules, write it separately. It's simple. Moles multiplied by Avogadro number means 6.02 into 10 to the power 23. Moles multiply 6.022 into 10 raised to the power 23. Okay. Now write it for number of atoms. Number of atoms, moles into 6.022 into 10 raised to the power 23 6.022 into multiply 10 raised to the power 23 multiply number of atoms. Whatever is asked in the question. Okay? Got it? Okay. Would you able to digest another formula if I give you? Would you able to? Okay. Okay. Then let's move to it would be the last one. I guess four or five are enough for today. Okay. The next one is Calculating the mass percentage. Mass percentages. Mass percentage. Mass percent. Okay. The formula is simple. Number of atoms multiplied by atomic mass divided by molar mass multiplied by 100. Because it's a percentage, we have to multiply it with 100. Okay, let's do it. Calculate mass percent of oxygen in water. Okay, it's a simple one, a very simple. Water is H2O. Is what H2O? Okay. How many number of atoms of oxygen are there? Because oxygen is in question. Wait, how many atoms? One. The atomic mass is 16. What is the molar mass of water? Hmm? Calculate. 18. 18 multiplied by 100. So what's the percentage of oxygen? Done. Is 88.89%. Round it off. Okay. Let me give the difficult one. Calculate percentage of hydrogen in sucrose C₆H₁₂O₆. 11. So number of atoms are 22 and their mass is 1.008. What is their molar mass? That you need to calculate, though I have calculated earlier. I've written over here. If you want help, it's written over here. 342. Okay, just divide it. 6.48%. Okay, you got it. Okay, let me give you examples for this one. More examples. Okay. I'm giving you question for each one of the following of what we did. Okay. Shall I give you a difficult one? No. Okay. Because there is like one step, we can go one step ahead. Okay. Uh, Try to find the easy one. Uh, Okay, then right. Calculate the percentage of sodium in sodium nitrate. Now you have to find the formula by yourself. I will not tell you the formula. You already know how to write a formula. Use the method if you want, so I would repeat that. Okay? But you need to write by yourself. Okay. Start doing this. I'll be writing the other questions. You can like do this. Okay, what if I give you mass in kg? Would you able to convert that into grams? Okay. How to do this? How to do? Wait, no, no. I'm just asking if like kilogram is given, how to convert it into grams? Good. Would it be divide or multiply? Kilogram into gram. Again, exactly.